Okay, so logic and set theory. So we're going to start with our set theory stuff. So I have a bunch of definitions to start with. So a set is a collection of distinguishable objects. So an example was the set of whole numbers. So do you guys remember what whole numbers are? You were supposed to learn this in grade 10. So I could do this. Whole numbers equals, and then when I'm listing a set, when I'm listing stuff, I actually use squiggle brackets. There's probably actually a name for that bracket, but I don't know what it is. Do you like my term, squiggle bracket? Okay, so do you know what whole numbers are? What's the first whole number you can be?
100.
0. 0 is the first whole number, and then 1, and then 2, and then 3, and obviously it would go on forever, so I'm just going to write some dots. Another example, if I say, can you write me a set of all even numbers from 1 to 20? So I'm going to go E equals, I'm going to use the letter E to represent this. You can, and then if I'm going to list stuff, I'm going to do squiggly bracket. So what is the first even number from 1 to 20? 2. And then 4, 6, 8, 10. Do you know other things, like, do you know what integer numbers would be? If I ever said the set of integer numbers? What from whole numbers to integer numbers, what else am I including now, all of a sudden, with integers? Negatives, yeah. Integers are all the whole numbers plus the added side of the negatives, right? An element is an object within a set. So you could do something like this. 10 is an element of even numbers. It's an element of even numbers. It belongs to that group. It's within that group. You guys have had this before. Haven't you seen that? Do you remember seeing that on papers? What does it mean? X is an element of all real numbers. So X can be anything. Remember the domains of stuff? Like negative infinity to positive infinity? It can be anything. But that's the little symbol. It's like a fancy E. A universal set is a set of all the elements under consideration for a particular context, also called the sample space. So if I wanted to do a universal set for this class, I would have to include everything, all of you. I'm just going to write your first initials so I don't have to write all your names. Bobby, Hunter, Kingston, Sean, Nathan, Smar, Aurelia, Cass, Drew, Maya. Okay? So it's a universal set, which means I have to do everything that's involved. It has to be there. A subset is a set whose elements all belong to another set. Okay, so I could do applied is a subset of the math classes. Okay, do you notice this symbol? Subset. Subset. Okay, complement is not belonging to something. So this symbol is the not doing something. So this is not even. So what would be included if I'm not even? What's the opposite of not even? Odd. Right? Not even. Complement is on something opposite. Okay. Empty set is a set that has nothing in it. So here's an example. I'm going to list you all the students that have 100% in the course. So I'm going to write down the names of all of you that have 100%. Sorry guys, it's empty. None of you have 100% in the course. Okay, it's empty. So look at me, I'm leaving it empty. You also might see this symbol. I think sometimes I've seen like this to say like, oh, okay, there's just nothing in there. Disjoint. Think about that word, disjoint. There's nothing that joins them together. So can you think of something that would never, ever, ever, ever overlap? Odd numbers, even numbers. If I wrote down the lists for them both, they would have nothing in common ever. I just wrote number, like odd numbers, like what is that, a pound symbol or a hash? No, that's a pound symbol, right? Odd numbers and even numbers, right? If I wrote the list of this and the list of this, you will never see a number in common, right? Okay, have you ever heard of the word a Venn diagram? Okay, so this is a diagram. So here we go. M is going to be all of the foods eating all the foods. D is desserts, favorite desserts, vegetables, and fruits. Okay, so do you notice that all of the foods that we eat is M? One of these doesn't work. This one. This one is out because you needed to have an M in the showing you. Here's the whole box has M's in it. All the foods. Okay, so this one is out. Okay, now let's talk about this situation. Vegetables is all alone on all three of them. Would you agree that vegetables can't overlap with desserts, and vegetables don't really overlap with fruits or desserts, right? Does anybody ever eat a vegetable as a dessert? No. Okay. So we know vegetables, we're good with that. Okay, so let's talk about fruit. This one has some of the fruits being desserts. This one has that no fruits are inside desserts at all. And this has that every single fruit is considered a dessert. Which one would you guys pick? I would probably pick that one. So what's the difference here? They have classified some of the fruits to be belong in there, in the desserts. So some fruits are also considered an overlap of a dessert. Okay, and I would do that, right? I would probably say, oh, strawberries, that's a fruit, but I would eat strawberries in a dessert, right? Okay, on the next one here. We have to draw a diagram. Okay, so it says the universal set is positive integers less than 10. Okay, so do you know what every single thing in this would include? What's the first positive integer? 1 is the first positive. 0 isn't positive, right? You guys know 0 is not a positive or a negative.
It's neutral.
It's what? Neutral. Neutral, yeah. 2, 3, 4, 5, 6, 7, 8, and 9. Why did I stop at 9?
Because 10 has a 0.
Because it tells me what here? I have to be less than 10. So if you are 10, is that good? Are you less than 10? No. Okay, so here we go. I'm going to talk about everything in this universe. Okay, it told me X is these. P is prime numbers. So let's list out some prime numbers here. Do you guys know what the word prime means?
No.
It divided by what? It can't be divided by anything except itself and 1. That's the only thing. Okay. 1, 2. You can only do 1 times 2. That's it. What about 3? It's prime. The only thing you could do is 1 times 3, right? What about 4? Not good, because you could do 1 times 4 or 2 times 2. What about 5? Yeah. What about 6? No.
So basically, odd numbers.
Not all odd numbers. Okay. 2 is actually the only even number ever, because after 2, any other even number is divisible by 2. So, 7 is 7. Yes. Is 8?
No.
No. What about 9?
No.
No, because you could do 3 and 3. Okay. You know what? I'm going to do that. I'm going to scratch 1 off. 1 is an awkward one. I guess they just don't consider it prime. Because 1 and something else. And then because it's just 1 and 1. Okay. Here we go. O is odd numbers. So what would you put in the list of odd numbers?
1.
1, 3, 5, 7, 9.
How far do we go though?
That's it. Because the
Oh, less than 10. Less than
the
10.
universe is this. This is my only thing I can ever pick from, right? Okay, let's talk about overlap. Okay, you know what? 5, look at 5. It's in all of them. It's in all of them. Oh, 7 is 2. And 3? No, 3 is not in the X.
Oh,
Yeah. So 5 and 7 are in all of them. But you said 3 was in that and that. Is there anything else?
2 and 2
Where else is the 2 in though?
The,
I don't think it's not in the odd and it's not in X. Okay, I think that's it, right? Okay, so here we go. X, P, and an O. Oh, I should have done this bigger. Okay. Ugh, I should have done this bigger. Inside the triple overlap, I need you to put a 5 and a 7. I gotta do mine way bigger. This is gonna bother me. Not a good diagram. There's my awkward diagram. Okay. 5 and 7. Do you notice how I've situated them in the middle where all 3 things are overlapping? Okay, so the number 3, it has overlapped the P and the O. Do you see where I've put it? The number 3 is an overlap with the P and the O, but it's not in the triple overlap. Okay, you see a difference? Okay, the number 4, 6, and 8. 4, 6, and 8 belonged to just X. They couldn't overlap with anything else. The number 2 was just inside a P with nothing else. And then we had a 1 and a 9 in the O. Did you guys use every single digit? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Okay. What if I didn't use something? Where would you put it?
on the outside.
You would put it outside the bubbles, but it has to be within the box, but outside the bubbles. Okay. So when we look at these Venn diagrams, the word intersection means and. So can you look at the digits? Is there something that belongs to A and B? Do they have something the same?
3.
3. A and B so this is the symbol for and. That's the symbol for and. When you are Venn diagramming it, this is and. Whatever's in the overlap. So this would have a 1, a 2, a 3. This is what it would look like. Okay, they both have that 3. It's the intersection, it's the and, it's the overlap. Okay, union means or. A or B. So when you have the word or, it's anything that you see. Can you list me anything that you see? 1, 2, 3, 4, and a 5. Those are all the things I see. Do you notice how I just didn't write 3 down twice? I don't do that. I just see a 3. It doesn't matter where I see it twice. I just see a 3. Okay? As a diagram, what does OR represent? This is an OR diagram. This or this, anything. Okay, here we go. Multiple choice. Number 1. Determine a, what is this symbol again? Or
B.
B. So that means I need you to figure out
All the numbers.
all of the numbers that you see. Which one of these answers is including everything that I see? The last one? That last one has everything that you could ever see in either set, doesn't matter. Question 2. What does this symbol mean? And. So now you're looking for what do they both have. So let's pick some stuff out. They both have a 0, I can see there. What else do we both have? They both have -6. +6. Anybody else see something? Is that it?
0.
Yeah, I got the 0. So they both have those items in them. So then
B.
B. Okay, so this is just some symbol stuff here. When you put an N in the front of something, it means the number of items in. Okay, the number of items in. The number of items in P, that would just be this one. This means that the number of items in T, but not in R. You guys learned this one, A and B, or. Okay, so here we go. Let's make a Venn diagram. Here's my universe. I have some A stuff, I have some B stuff. Okay, let's talk about anything that's in A and B. Let's go through that first. Do you see anything overlapping here? 6. What else? 12. Is that it? 6 and 12? Done? 6 and 12. Okay, now what's left to go in A but wasn't involved in the overlap? 3, 9, and 15. So the same thing with B, you have a 2, 4, 8, 10, and 14. Okay, let's go through your universe. Did you use up everything?
Yes.
2, yes, I see it. 3, 4, 6, 8, 9. Yeah, I think so, right?
Yeah.
Okay. All right, here we go. The number in A. Can you guys count how many things you have inside the A bubble? So here's the A bubble. 1, 2, 3, 4, 5. You see it? All right, same thing here. What's the number of items inside the B bubble?
7.
1, 2, 3, 4, 5, 6, 7 items. This says how many items are in A, but you can't put them into the B. They can't be inside a B. So what would I be looking at if I'm in A, but I can't be inside B? There's 3. So what am I looking at? I'm in this A bubble, but you can't. You have to cover up this B. You can't be in B. So I'm left with 3. Okay, can you reverse it over here? How many are in the B bubble, but not inside the A? So I'm actually going to cover up the A. So how many are left inside B? 5. All right, A and B. This is the and. So how many items are included in both bubbles? A and B. They have to be inside A and also inside B. 2. Because what are you looking at? The overlap.
And then ors and
How many are in A or B? They just have to be anywhere inside the bubbles. Anything? There's 10. How many are, do you remember this symbol? What does it mean, like tick mark? Not. How many are not in A? So I'm going to actually physically cover up A. You can't be in A. So I'm going to cover up A. How many are you? 5. Okay, I got 2 more questions here. All right, here we go. First one, this is an and. What is H and C? That's the overlap part. So we're looking
spinach, apples.
fish, spinach, and apples. And you know what? You have to write it out and list it. Because this doesn't ask you for the number of items. This says what is in H and C. What is H and C? Fish, spinach, apples. So I'm making a list. Okay, this has an N in front of it. So here I just want you to answer me with a number of items. H and C. It's the same thing as this question, except for it says the number of items. So how many items were in there? 3. So do you get the difference here? This says H and C, so you list me the options. This says the number of things. The number of items, so here we're going to answer with a number. Not H. So you know what I'm going to do? Cover up H. You can't be in this H bubble at all. So I'm counting. How many items do I see? I see 5 items. This one is an or, so this could be anywhere inside H's or C's, anything. So everything you need to count up, I see 10 items. All right, this next one doesn't have an N in front of it. So if it doesn't have an N in front of it, you know what I'm doing? I'm writing you a list. I'm making a list. Okay, this says H and C, but then I don't want to be that. So what is H and C? The overlap. And I don't want to be that. So what's everything else? So I covered up the overlap, and then, Okay, I'm going to abbreviate here. Cuke, let, chick, rice, pass, pour, pot, tate. Sorry, I'm just trying to save time here. Okay, so I'm listing. And the last example, there's no n again. So what are you doing if I'm not asking you for the number of items? I'm asking you to list me them.
Wait, what does the slash mean?
Okay, so this says I want you to be inside C, but you are not allowed to touch H. You're not allowed to be in H.
Oh, okay.
Okay, so this is the C bubble, but, oh, I can't be in this H. So this is what I'm left with here. Chicken, rice, pasta, pork, and potatoes. Okay, does that make sense? Understand when I'm asking you to list me them, and then otherwise I'm asking you to just, how many are in there? Okay, so now I'm going to do the last question, and then you can go. All right, you know what let's do first? Let's talk about which one am I making a list on. Should I make a list or give you the number?
List.
List. So I'm going to start that with a squiggly bracket. This would be a list of something. This one, you're going to just give me a number, right? What are you going to do for this one? A list.
Number.
I'm going to want a number, and I'm going to want just a number. Okay, ready. First one says you have to be in the A bubble. You have to be in the A bubble, but you can't be in this B bubble at all. So what am I looking at?
1 and 2.
1 and 2. They're inside the A bubble, but don't be here. They're in this bubble, but not there. Okay, this says not B. So you know what you do? You cover up B with your thumb. So if you don't want to be in B, what else do you see?
1, 2, 7, 8.
1, 2, 7, or 8. You're just not allowed to be in the B, so anything else goes. The next one says A and B, but then not there. So let's talk about what does A and B look like. The overlap is the A and B, so I don't want to be there. So I'm going to cover up that. So how many, we're just doing a number, so how many digits do you see? So you see 7 items. This one says A or B, and then not there. So what does A or B mean? Anything in AB bubbles, anything in the bubbles, so then I don't want to be there. I don't want to be in bubbles anywhere. So what do I have?
7, 8.
I have a 7 and an 8. Oh man, I made this next one is really tricky. Okay, I'm actually going to list these because this one is tricky. Not A. Can you make me a list of things that are not in A? 4, 5, 6, 7, and 8 are not inside A at all. What digits are not in B? 1, 2, 7, 8. Okay. So if I was to write a list of the or, what do I see in this or that?
7, 8.
You would see, no, or. The or is anything that you see. What's anything that you see? I see a 1, I see a 2, there's no 3, I see a 4, 5, I see a 6, I see a 7, and an 8. So,
But doesn't the slash mean not?
there's no slash.
Yeah, it is.
Right
No,
here.
not the slash, the little comma.
What?
The,
I'm just writing a list right now.
like on A and B, there's the little,
A not.
yeah.
Yeah, we did the not. Here, this is
Okay.
the not part.
Yeah.
Not in A. Not. Yeah. So here's the list. How many are in my list? 1, 2, 3, 4, 5, 6, 7 items.
I don't get it. But
Well-
isn't it not in A or B?
Yeah, we listed. This is the list of things that are not in A. And then this is my list of things that are not in B. Now I'm saying
Oh,
what's
those things
what's
are
in
not.
here or here? What do you see in here or here?
Right.
Okay. Now we're going to do and. So what's in this and this? And we've already listed all this out. So can you just look at your list? What do you see in both of those lists? I can see a 7 and an 8 in both of them. So then my answer to that is that there's 2 items that ended up there. Okay, so that I made a list because I find that really hard on the diagram.